Hello everyone, I am Ananya Borkar and today I am going to present my topic on architectural styles and logical clock algorithms in distributed system. This is a part of DCC, distributed cloud computing for ISC1. In this presentation, I will explain first the distributed system, then discuss how distributed systems are organized using different architecture styles, and finally explain the logical clocks including Lamport clock and vector clocks. So, moving towards our first slide, what is distributed systems? How many computers works on as one? Let's begin with simple example. Suppose I am shopping online and I want to buy and repair my running shoes. For my first For my first site, it looks like I am performing just one action. I click buy now. But behind this simple action, many computers and systems and services are actually be involved. For example, there can be user services, product services, order services, and payment services. Database also. These different components communicates with each other and coordinates their work. So even though many independent computers are working in the background as a user, I experience it as a one single service. That is a basic idea of distributed system. In simple words, one system can consist of many computers that communicate and coordinate to the provide one united service. So, what makes a system distributed? Now let's consider what actual makes a system distributed. Again, the consider from same example of placing order, I can make one user request from my phone. But behind the scene, many computers are involved. The product service may check whether the product is available or not. Payment service verifies the payment. Order service process the order, and the database store the required information. Finally, these independent activities produce one final undefined result, that is order confirmed. So there are four important characteristics shown in this slide. First is multiple computers are involved. Second, these computers communicate through a network. Third, the different components can perform their work concurrently, meaning they can be work independently at the same time. And the fourth one is they may share resources and information. Therefore, distributed systems can be summarized as many computers independent tasks but one coordinate experience. So now we know that distributed system is what is the distributed system. Like, the next question is, how do we organize all these components? This is where architectural styles come into the picture. In the architecture style defines how the components of the distributed systems are organized and how they communicate. There are four components. The first is client server, second multi-tier, third peer-to-peer, and fourth is microservices. So very first is a client server. The client sends requests to the central services and there the server proceeds. Then multi-tier. The system is divided into layers such as presentation layer, application layer, database layer. Then peer to peer. Here a computers or the peers are communicate directly with each other without depending on one signal server central service. Then fourth is microservers. A large application is divided into smaller independent services such as user, product, order, payment, and daily services. So main idea is the different architectures organize the same distributed components in the different ways. One order, four architectures. Now let's take a same e-commerce order and see how it works through all four architectures. Suppose I am purchasing wireless headphones for 2499 rupees. The business goal is simple. I want to order to be a successful proceeds and delivers. So, but internally, the organization can be different. In client server, may my client application communicates with the central server, which processes the request. In multi-tier, my request passes through the different layer like presentation, application, database. In peer-to-peer, different peer communicates directly and share the required orders in the information. In the microservices, the application is divided into independent services. For example, user service, product service, order service, payment service, delivery service. So, even though the final business is the goal is the same, the internal organization is different. That's why we can't remember the slides with one sentence, same business goal and different organization. Moving towards the next slide, now this slide summarizes the complete journey we have covered so far. So we started with many computers, then we learned about architecture, which decides how those components are organized. Next comes communication, because these components needs to exchange the information. And finally, we need a logical time to understand the relationship between events occurring across the different components. The final goal is a coordinate distributed system. For example, the order service, payment service, and the delivery service must all work together so that we can get order confirmed, payment proceeds, and delivery started. So, the complete concept can be remembered as architecture, organization, organize components, communication connects components, logical clocks helps order events, and together they help create a coordinate distributed system. Now let's moving to the second major part of the topic, that is logical clocks. In the distributed system, different computers do not necessarily have perfect synchronized clock. So instead of depending only on a physical time, we can assign logical timestamp to the event. There are two important approaches shown in this slide. First is Lamport clock and second one is vector clock. So moving very first, like Lamport clock, the Lamport clock assign a single logical number to an event. For example, 1, 2, 3. The process sends a message, timestamp can be attached to the message. When the another process receives it, it updates its logical clock using the received timestamp. The important idea is if event A is happened before event B, the logical timestamp of A should be smaller than that of B. So Lamport log is equal to event order. Now let's look at vector clock. Instead of using single number of vector, it maintains vector of the number representing the state of the multiple processes. This gives us information about the relationship between events. Most importantly, vector clock can help identifying the concurrent events where neither one happened before their others. So we can remember Lamport is what come before and vector is what caused what or where is the event concurrent. So finally, let's understand why we need logical clock in the first place. Imagine if we have two processes. Process A is order service and process B is payment service. Or process A creates a order and sends you message to the process B. The final problem is that process A have their own local clocks and process B have their own. So if we simply look at their physical clock values, we cannot reliably determine the relationship between events. This gives us the important idea. Real time is not equal to the event order. Therefore, the distributed systems needs another way to understand the ordering event, and the solution is logical clock. Logical clock do not measures actual real world time. Instead of, they help us establish meaningful relationship between events. So, to concluding my presentation, a distributed system allows many independent computers to work together as one coordinate system. The architecture style defines how the components are organized. We discussed client server and multi-tier peer-to-peer and microservices. But because distributed system computer operates independently, there is no perfectly reliable global clock. So that we introduced logical clocks, Lamport clock and vector clock. Lamport clock established event ordering, and while vector clock is provide additional information about concurrency. So the entire topic can be remembered as this example in the one statement that architecture organizes components, communication connects them, and logical clocks helps us understand the order of the event. Thank you.